No worries, no worries, no worries. Back to our regular scheduled programming. So yeah, Dr. Mike, welcome once again. Um, I believe Kat had sent you over some questions. They were kind of like some introductory questions, some refresher questions, just for our listeners, and anybody who's new to the conversation regarding these updates. And then, we'll get into it. Floor is open. But yeah, I just thought that it'd be fun to just kind of open up with some of those questions. So, not sure if you have had an opportunity to open, I guess, the DM to just see what the questions were.
So I did open Cat's DM and I read the questions and I thought about them a little bit, and so I'll just wing it as you ask them to me again.
Oh, okay. Yeah, we can do it. Okay, guys. So we're just gonna start from the very top. Just these are just like 5 questions for Dr. Mike Heffron. So, question number 1, Dr. Mike, what is a celestial theodolite, and how does it differ from a standard theodolite used in surveying?
Celestial theodolite, in a lot of ways, is very similar to a standard theodolite, a terrestrial theodolite that's used for surveying. But unlike a terrestrial theodolite, which is a physical device, celestial theodolite's more of a concept. So in a terrestrial theodolite, you have an eyepiece and you look through that and you sight whatever you want to see. Well, in the celestial theodolite, the eyepiece is either your eyes or binoculars or a telescope. And for best results, you probably want to use a telescope, because what the principle of the celestial theodolite is, we use a mountain peak as the horizontal crosshair, and we watch for stars to be occluded by the peak. And then once the star is occluded by the peak, we note the time, and we already know what the peak is. So you can visit Stellarium or your favorite astronomy tool, or get out the Nautical Almanac and calculate yourself. But what you want to do is find out what was the elevation, and we're talking about the true elevation of that star at the time it was occluded, not where it appears to be, but where it actually is. And using that elevation, that's the angle your celestial theodolite just read. So now all you have to do is take the tangent of that angle, multiply it by the distance to the peak, and that tells you what the rise of the peak is above the level of the observer. So add to that the altitude of the observer, and now you have the altitude of the mountain peak. And unlike terrestrial theodolite, which is affected by refraction and atmospheric conditions, the celestial theodolite is not affected by any of that. So you get an extremely accurate, extremely repeatable elevation of the occluded star that you can use to calculate the height of the peak without any interference from refraction.
Yeah, no, and I was just gonna say he basically summed up the other couple of questions. Sorry, Jamal. Oh, not sure
So
if you.
you said my name? Sorry, no, that wasn't me. It's
Oh, I
some.
thought that you were okay. Never mind. Okay, so yeah, Dr. Mike, and thank you for summing that up. Like I said, you did that beautifully. So you basically answered basically most of the questions on here. Um, I was there. There's two. So one that I am going to ask, and then one that I'm going to leave for our boy Coffee here. I'm sure you're familiar with Coffee. I know Ether causes. It was something that was discussed earlier, and before I'll let you guys get into it, after I ask the other question, but it's regarding the J factor. So that way you guys can get into it. And just basically, like, for the room, what I'd want is just basically, what is the J factor? Why did it need to come up for the correction, et cetera, et cetera? What would be the, on the opposing side, aka the globe side, why do they object to it? Why are they trying to say that it could be something else, or it could be, an error, etc. But the question that I'll ask you, and I'll let you guys do the J factor, So now that we've had a couple of these and there have been updates, and I know that you guys are constantly updating online, have there been any discussions, and I'm sure this goes without saying, but just for the room, in Ether Cosmology Discord that have helped you refine your theories or led to adjustments in how you're interpreting the theodolite data? And this not only goes with just talking to like the flat earth side, Dr. Mike, also even like when you have objection or pushback from the globe side, like how does that help you refine your data?
So I think the biggest way that it helps is it lets us know what people are having trouble understanding. So some people accuse me of rambling, which is not an unfounded criticism. Um, and so I'm trying to be more precise, try to listen to the concepts that are confusing or being misunderstood, and in ether cosmology, when we have discussions, it's usually what's a better, less confusing way to present this. Um, uh, and my professors, when I was a student, they were always criticizing me for I do what they called a logical leap, where I just did not explain something I thought was so obvious that everybody would understand it, and it didn't need explanation. And they were constantly calling on me on that and asking me, "Well, how'd you get from here to there?" And so Q&A helps with um, uh, emph- finding a different way to emphasize important concepts that may not be well understood. And when we get into the J factor, that's going to be one of those that people are totally misunderstanding the purpose of the J factor, and they misportray what it's actually doing. And in my mind, the whole concept is real simple. It's actually your question reminded me of something I should have said earlier, and I apologize for answering too many questions at once. Because that was an unintentional, but the a very very important part of the uh, celestial theodolite that I kind of glossed over was the importance of the mountain peak as a crosshair, because the before the celestial theodolite, people would measure mountains with terrestrial theodolites, and they'd get all kinds of different altitudes, and they were generally portraying those as globe Earth altitudes, um, and the original intention of the celestial theodolite was, well, we know the height of this mountain peak, so if we see the mountain peak occlude the star, that's a good horizontal good horizontal crosshair. It's an object of known height, and now we can just look up at the elevation of the star at the point that the peak occluded it and see, is that a flat Earth angle or is that a globe Earth angle? And from the very beginning, it was all flat Earth angles. So at the time, um, my whole history has been a globe Earth guy, and that's what convinced me, no, the data is showing the Earth is flat, or that could not have happened. It came out the one angle it could not possibly be if the theory that the Earth were a globe was true. Because what I was doing is I was trying to refute the null hypothesis that the Earth is flat. And I couldn't refute it because it came back with a flat Earth angle. So, and after that, I went on to other mountain peaks, and it's the same principle, and it's the same pretty simple every time. And I don't know if I managed to answer the question somewhere in there.
Hey, real quick, so I know Liz gonna hop back up in here, and I know Coffee had a question, but I think you brought up something that I think it was gonna be my question, right? Because a little birdie told me something, and I was just curious as to, I said, you know what, I'm gonna ask him next time he's around. is it true that you were a secret flat earther before you started the
Oh, then
celestial
you stole
theodolite?
my thunder, bro. I was literally, you stole my thunder. I was setting it up. You told me, hold on, it's
Where
my
you?
setup.
Hold on.
I got a different setup. Let me ask.
Go ahead. You go
Because
ahead. You
this,
go
I
ahead. Go
found
ahead.
myself defending Dr. Mike the other day, and I said, wait a minute, why am I defending this guy? What do I really know about this guy? Because rumor has it that you played a really long game, like you were really a secret flat earther, right? Because I told someone that you weren't really a flat earther, and they said, well, that's what he says. And I said, well, it seems like the rumor is that you played a really long game to do this flat earth reveal and reinvent yourself as a flat earther. So I guess you went house shopping on Zillow to cherry pick a house that had mountains outside that landed in a range of cherry picked data that would match a flat earth observation so that you can come up with this whole celestial theodolite ruse, because that's kind of the rumor, what the rumor mill's been on Clubhouse has been.
What?
So I said, wait a minute. I had to think about it for a second. I said, you know what? I don't know that that's not true. So let me stop defending this guy and give him a chance to defend.
I mean, if you were going to no hypothesis it out, that would be the way to do it, right? Like,
Hey,
can
you
you
know,
falsify
I
the
can't
alternative?
falsify that. I don't know. So let me ask you. Let me ask the guy in the flesh. Like, is
Let's
that
get to the
true?
bottom of it.
So
So
Zillow has
I'll give you
exclusion
a
spots.
I'll give you a really direct answer to that question. No, I was not a secret flat earther, and I lived in this house for 11 years now. Um, and at the time, I was working for a special access program that's heavily involved with satellites. And in fact, my whole career, I've been involved with satellites. So I was definitely very indoctrinated into believing that the Earth was a globe. And until I got hooked up with the Aether cosmology group, it never occurred to me to ever take the concept of a flat Earth seriously. But I began listening to their debates, and they were really interesting. And the gears in my brain started whirring, and I came up with this idea I thought would be a way to actually that maybe it could be successfully tested. So I asked Alan about it over at Ether Cosmology, and he thought maybe this technique had promise. And I just started taking videos with my telescope and analyzing the data. And uh, when my first few measurements came out flat Earth, I was definitely surprised. And I think by the second mountain peak that I did, I thought maybe I started with Pikes Peak, and I thought maybe that was just a fluke. And by the second mountain peak I did, that was enough to make me realize
Is that me?
Did
that
he cut out for
is
everyone
that the
else?
Earth is flat.
Yeah, we lost him for a second.
We lost you
Mike,
for
we
like
lost you
5 or
for
10
about 10
seconds. So.
seconds.
Mike, after you said
Well,
after the third measurement, then it went blank.
oh, okay. So after that measurement, that's what turned me into a flat Earth convert. That's when I realized the data is clearly showing I cannot refute the null hypothesis that the Earth is flat. Therefore, the Earth must be flat. Um, and with more and more data, it's just becoming clearer and clearer. If you look at any of the graphs in any of my spreadsheets, you can see that the globe Earth measurements are above and below us, but the flat Earth measurements are all right around
Is
small
that me?
deviations from the zero. Oh, sorry, what was that? If there was a question there, I
Is that
missed
me?
deviations from the
Nah.
zero.
So hey Mike, have you ever heard that the universe always balances itself out?
If there was,
You ever heard that
I've
concept?
heard that said.
See, so
I've heard
to
that
me,
said.
it seems like because they took Jaren, the universe had to balance itself out, and so it forced you to come over. So you know what I'm saying? All right, I'm cool.
But
Go
Dr.
ahead, man.
Mike, what kind of sorcery is going on here? How is this method immune from refraction?
And
So
here we go.
that is that is by design. I, as I began looking into what was being done, I realized refraction is the only thing um, that's giving the false appearance for terrestrial measurements that the Earth is a globe. And all, the illusion of a globe is all in the refraction. So my first thought was, well, what can be done to eliminate refraction? And that's what I was looking out the window at Pikes Peak at the time, and I was thinking, well, if you watch stars being occluded by Pikes Peak, I know the altitude of the peak, um, and um, when the star goes away, there's no refraction involved. I know that that's where the starlight intersected the peak. And so now it's just a matter of looking at what was the elevation of that star. And lo and behold, the elevation of the star is the exact elevation that the flat Earth angle should have been from my house to that peak.
See, the thing was, once I first heard it, I thought it was ingenious, right? Obviously, but I didn't have my hopes up too high because of, like, for instance, the Mount Canada observation, where I've heard, countless experts and science people come and globe heads come in and say that the mountain that's blocking the sunlight and creating a silhouette, that's being refracted up, and so is the entire sun. It's that sun's also not where you see it; it's completely under the horizon, and all of that entire scene in front of you. So there's a refracted thing blocking another refracted thing. So once I heard that, I said, "Oh, there's no, they won't. It ain't shit for them. They're gonna refract the mountain and the star wherever they need it to be with with carte blanche and no qualms about it." And I knew they would, and sure enough.
Give them their refraction, and it's still off.
Exactly.
Yep.
Which is
Or you
why
can
the
do
whole
it.
notion that Mike like cherry picked somehow by using the I said, to me, what I see, like, I haven't gotten, I'm math lazy, I haven't combed through all the data, I'm just kind of listening to the argument. And obviously, as far as logic and like Occam's razor and reasoning goes, it seems like the flat earthers are having a degree of randomness here, that the globe earthers, they can randomly pick places and use their assumptions and make predictions, actual true predictions. And it seems like the globe hasn't done that yet. So until I see that from the globe, I think the flat earthers are proving here that they have a better, more salient, predictive, more efficient, by definition, predictive model, because they don't, they can make predictions and, with less. You need more to act like you're making a prediction. It's not really a prediction at all.
Or you can do it the John way. I don't know if y'all familiar with John Mallinckrodt. You can do it the John Mallinckrodt way, and we're gonna start with the answer. Like just do it my way. We're gonna start in Stellarium, and Stellarium is going to tell you where the star will be, and then like so it's like he goes back. He starts with the answer and goes backwards. So
Yeah, one other problem that our Globe Earth friends have is because their methodology is so heavily dependent on refraction, which is all over the place depending on temperature and pressure. That's what makes it hard for them to predict anything. Um, and my very first measurement, I just put my little telescope on Pikes Peak and let it record for a couple of hours all the stars. And after the fact, I looked up where what was the elevation of those stars when the peak occluded them, and that that's probably when I started considering maybe the Earth is flat because they're all coming back at a flat Earth angle. And so, but somebody could drop you in the middle of nowhere. You cannot even, you personally cannot know where you are, and you can watch a peak occlude stars and write down the time. And if they know where you are after the fact, they can verify whether the elevations of those stars give you the proper altitude for the peak. So we definitely have that. We have very very good predictive power, whereas our globe Earth friends can't predict because they're hostages to refraction.
Okay, so what do you say to someone who says, well, right from the onset, you need data from a model, right, from a celestial sphere, or from a what do you call it, stellarium model, and that ipso facto equals globe, right? That is a globe, so we win. What do you say to someone who wants to claim the positions of celestial bodies as exclusive to a globe? How do you prove? I mean, how do you, how do you borrow what they think is theirs exclusively?
Oh,
Like, what do you say to a person who thinks it's theirs exclusively?
I would love to follow up on that after Mike answers.
Can you use stellarium data and and then somehow claim
I would
that
love to
it
answer
relates to a
that
flat earth?
after Mike gives his answer as well.
Sure.
I don't consider myself an expert on how to answer that question in a meaningful way, and that goes back to my problem with not always being able to explain something that I consider to be so obvious that I would think everybody would know the answer to it. And this is one of those things. I know they've latched on the celestial sphere as theirs exclusively, but that's actually a fairly recent development when you research um, that really only goes back to Ptolemy in the late 1400s or early 1500s, and before that, virtually everybody assumed that the Earth was flat, and it wasn't until roughly 500 years ago that people began thinking, well, maybe it's a globe. And even when Columbus allegedly sailed to America, they were worried which was just barely over 500 years ago, they were worried he'd sail off the edge of the world. So I don't think this is something they own as much as they're trying to convince people they own it. And now I'll defer to Alan, and he can give a much better explanation.
Awesome, dude. Well said. Give me 1 second. Let me pull up my Canva real quick. So I'm having Kat put some links in the chat for us. One of the links is the Discord link to the Flat Earth Gang Discord. Nothing official has been done there yet, but there is a Discord that's been constructed that will be useful in a future time. But there is also references to images that Shane's going to be covering tonight and things that I'm about to reference right now. So if you want to take a look at it later or whatever, it'll be permanently parked there. And then it'll also be in the chat here for the Clubhouse permanent lads. But what I found on Tuesday was that the prior to like the mid 1800s to early 1900s, the Buddhist in Japan, the Shintoist in China, and I forget the other one, but basically every Asian culture was a flat Earth geocentric cosmology. And specifically during the mid 1800s, uh, when the Jesuits came in, they pushed heliocentrism, the Earth as a globe. They pushed the solar calendar, and Christianity. And the Buddhist monks started using like their own optical arguments against them to show how unreliable their conceptual model was, because the way that the Buddhist monks had conceptualized it was that the world that we see and that we live in isn't exactly the true world, right? And especially when it comes to the heavens, what we see is like obfuscated and apparent to us, and there's a true heaven that that the motion of the bodies belongs to. And then what you can see here in the Canva link that Kat just posted, that first image on the bottom right, you'll see a little disk model with a bunch of celestial spheres in it, and it's just the hemisphere. Right now, keep in mind these are flat earthers with a celestial sphere model, just using uh, the top hemisphere, because all one observer ever sees at one time is their hemisphere of the sky. When the stars are out of your vision, right? There's two options. They could be beneath your feet because of Earth ball curve or something like that, or it's an optical effect and they're out of your vision and they're circling above you. Now, these guys all had determined that it was the circling above you, And using the exact same model, they were all able to navigate. You can look into the story from, so keep in mind, like this is 1800s, like mid 1800s. These guys were flat earthers. They could all navigate. They had uh, their empires have been sailing and all that. You can look into the Chinese expedition in the 1400s, even, where they basically sailed around the entire world using worm line sailing, and that was obviously redefined when Mercator came around to make it about being a globe and all that. And Shane can touch on that for the specifics, but the point is, using the using just the what you see as your hemisphere, they mapped out the entire world and was able to navigate it. And so that's not mutually exclusive at all, like the celestial sphere. What is mutually exclusive is when these Christians came along, they introduced the terrestrial sphere, right? So what Mike had just touched on, the with Ptolemy, is the merger of the celestial and the terrestrial sphere. So that's merging these two models to relate positions of the stars to positions on the ground. And previously, navigation was done by going to nodal points and then adjusting your bearing, and then just following your bearing to another point, another known point. And people had their own maps, their own charts, etc. And then there appeared to be one universal one called the Perry something map, and that was there's like a fragment of that, and it uh, details where the Chinese were when they were doing their expeditions in the 1400s. So there's
The
a long
Perry Reese map,
history.
right?
Yeah, the Perry Reese map. Thank you. There's a whole history of world navigation. And anyway, we're told a specific narrative of like this terrestrial and celestial sphere narrative that's presented to us by the Royal Society, and that's basically it. The way that they made that model work, of course, was using a fictitious observer tying tying all the positions in time to a specific uh, point, and then adding 15 degrees per hour to that. So we're actually using we're using their framework to test it, because units of measurement are derived from their coordinate system, from the latitude and longitude system. A meter is a ratio of a terrestrial meridian being a longitude line. So they
It's like 1/10 millionth or something like that, or like the minus
one
stuff.
exactly 1/10 millionth of it. So it's internally self-consistent. So if you're referencing the system within it, you will never find a contradiction. So that's why
Man, it's a
Mike.
loop. I tried to explain this earlier. It's like a perfect loop that they interlocked and interwove all of the shit into. So
Yes,
got to
sir.
be
And Mike,
really fucking keen to pick up on it, you know. Otherwise, your end user experience, it all just works out swimmingly, and you would never really ask any questions.
exactly. And like my boy Copernicus once said, if you're making a model based off of apparent positions of bodies, you could say anything you want, and whatever is easiest to teach is what we're going to use, and we'll use whatever we need to make our math work. And that's in regards to refraction corrections to change the positions of the stars to where they need to be to make sense with 15 degrees per hour, to make their coordinate system work, because they relate time to angles to the stars and vice versa. So if you know a specific time, you know what angle that star's at, because they took snapshots of all the stars that they use for navigation on the first cusp of Aries, and then you add 15 degrees per hour to that. Well, that's where they come up with the concept of a true position and an apparent position. So the true position would be that star's zenith position on the first cusp of Aries. If somebody were standing directly under it and looking up, where it would be, and then adding 15 degrees per hour to that. And then so when you are at your position and you're looking at it at some angle, well, it's not going to be exactly one to one the same. So they have these corrections that they apply to make that angle adjustment correspond to the correct time, if that makes sense.
Right. No,
It's
I
like
mean, I tried to explain this to someone earlier. Kind of asked me, I forget the name of the word, but it's like, so you have your zenith star, and I guess it's the antipode star right under that. I forget the name. Somebody hit me
the
with a term.
nadir.
Yeah, the nadir or whatever it was. And they were kind of trying to ask me about that, as if, that obviously means that it must be a terrestrial sphere as well. And I was trying to explain, to me, it's just like, hey, if I'm standing in one position, I have an observatory here, and I see a celestial object, travel, it entered my horizon on this azimuth at this angle, it left, and I clock it on the time that it comes back around. Like, I can just treat it like a circle mathematically. I can just create a circle with a period and create like a ratio, and whether it went under my foot because of ground curvature or whether it just went that away and came back around doesn't really matter to me as I construct a model that just kind of describes its orbit, right, in terms of its
I do
period.
have I do have a question though, Jamal. Like where we are, where I live in New Zealand, right? There is a particular time of the year. It's called Matariki, where there's stars in the northern sky above the mountains that they're only visible for like a couple of months of the year, and then they disappear again back over the horizon. Only visible for like a couple of months of the year, and then they disappear again back over the horizon.
Well, dude, it's so good to hear all the boys say all my favorite arguments so eloquently. I'm just saying that, but in relation to the stellarium, like it's referencing the true position. That's all we're using it for. It's not globe math. It's an agreed upon position of a celestial body that gets entered into an almanac, which gets put into ephemeruses, which get loaded into a celestial sphere model, which gets spun around at 15 degrees per hour to simulate a day and its position throughout the day. That's really all it is, as Alan eloquently pointed out. The other thing they say a bunch is where do you get your distance, right? And I think it's from block whatever the Graticule utilizing website was. But the point is when we grab that distance, both the globe and flat are utilizing a triangle to calculate that baseline distance, right? So that's a flat plane. And then we're applying a geometric Earth curve correction to that to accommodate for their side. So the fact that it's the same distance for both and that we're both utilizing triangles, I mean that's kind of silly. But also,
Yeah,
like,
but no, but Shane, that
I got a
wasn't
question
anything
for
to do.
Mike real
That
quick.
yeah, but your thing wasn't
that wasn't
related to what we were
anything to do with
doing.
my question. Like,
Yeah,
the
that was
question
on
was why?
purpose.
Why?
Hey, please
Uh,
don't interrupt me.
oh, for fuck's sake, guys, fuck you, sir.
Hold on, man. We have guests in the room today. You ain't have that type of attitude. Just having a good conversation. You're trying to give it.
But Jesus, I was only asking one question, and it was related to what you were talking about, and I was just wanting to know. And then the two of them, like Jamal and fucking Shane, dismiss people. You'll never have a fucking group big enough with this attitude.
Who did I dismiss? Even come off the mic. Why you saying my name, bro? Relax. But we can
Which are
keep
cool.
moving right along because I don't
Or
know what's
never mind.
happening. Yeah. I don't know. Is anyone? Did you satisfy? Like I don't know what's happening, but I didn't. I didn't interrupt. I didn't. You just asked your question. I didn't. Well, my name is being brought up, but yeah, like the question I had was right. So I understand these are really big undertakings, right? It takes a lot of the king and queen's money and foot soldiers to actually do this. My question, so I understand why we're stuck kind of retro, like kind of reverse engineering what was done, and we're stuck with this coordinate system that they put together for us. But my question is, they won't admit it outright and say, "Hey, it's a philosophical assumption that we were trying to flesh out." What would they say is the reason or the necessity? Like I guess since Ptolemy's days when he's coming up with this in our geography or whatever, he's coming up with this two sphere model where you have a terrestrial. What would be his reasoning for going with a terrestrial sphere? Why couldn't he? Why couldn't you use a celestial, or two celestial hemispheres or celestial hemisphere in a terrestrial plane and then create the system? Right? Why? What would be their argument or their steelman? How would you steelman their justification for going terrestrial sphere?
Okay, so in order to relate it all into a unified coordinate system that they could project that's spherical, they uh, they have to tie all those positions to they have to tie all those zenith positions to a position on the ground, right? And so to do that, they use the fictitious observer to do that at the center.
At the
So
center, right?
so to use their version of the celestial sphere model, you have to incorporate a terrestrial sphere where you can use a fictitious observer for a comparison. Because what you'll notice when you read through these old almanacs and the supplemental correction tables and all that, and like how they came up with them, what they say, part of the transformations that they do are called geocentric coordinate system transformations, and those are zenith position. That's the true position zenith measurement that I was talking about earlier, where they took a snapshot of the sky on the first cusp of Aries to make everything relative to that. So to make the time comparison to get the angles to work, they move you to the center of the terrestrial sphere, and move the celestial objects to the radius of that. So the way that they'll word
Wow.
it, or an easy way to get you to conceptualize using the two, because because if you're going to use their version of it, you have it corresponds to time, and to correspond to time, you have to use their positions. So let's see here, what was I going to say? The
Okay.
geocentric coordinate system transformations. That's the comparison where you find out where the star is at now, so you can find your latitude and longitude. Because if you know the time, then you know how much that star has moved since the first cusp of Aries with respect to 15 degrees per hour, and then you know where that's at, or then you have your Greenwich reference. So when you add your local time to the 15 degrees per hour, accounting from like the zero longitude, you get where that star is at, and that'll be your longitude.
Right, no good. Like you definitely gave me an answer as to why they did it that way. But what I want you to try to do is maybe see if you can find a way to answer it while shitting on, like, cause I remember I heard someone say it once and it made me think, it's like, that is true. They were saying, even though you were saying, I can't remember who was arguing, it was one of you guys' arguments, and they were saying, they put you at this imaginary position in the center of this presupposed sphere with a radius value, whatever. And then they were saying, so if you shoot out an angle from that to the, let's say, by the time that angle goes from the gobstopper core, soft chewy core, until by the time it reaches the surface, it represents a position from there too. It's the same as if it was from the core, or if it was, but then if that is the case, if you do just deal with the angle from the surface and ignore the fictitious position in the middle, well, then you could use a plane now, couldn't you? Because pretty much you are treating your local position as a plane, and a flat baseline of it. So I guess what I was trying to ask you to answer the question is in a way that, imagine you were them trying to sell your two-sphere model and the necessity for using a globe, which you did, but you didn't tell me why you would fail if you tried to create a
Oh,
plane model. Like,
so
why do
so
you
so like
need
so
it?
like
Why
why
can't
so
you just
why
use a
theirs is
plane?
mutually exclusive and more better?
Right, right,
My bad. I apologize.
right.
I
That's all
see.
I was asking you to be a
So
salesman, snake.
this is actually something that I found with the Buddhist stuff on Tuesday. Is they not only introduced their model, based on astronomy, but along with that came their teachings of Newton's laws, and basically,
Uh,
they were saying that this is the true positions of the heavens, and the Buddhists were like, "Yo, what are you talking about? We only see the apparent positions." Because what this is an illusion. The true bodies are, in a different position, and they had their own model for that. So the true selling point of it was making like turning the heavens into physicality, like applying like, oh, that's actually another rock, and we weighed it and it weighs this much, like all
dynamics. You
those,
got to sell the
all
dynamics with it.
the dynamics. Yes, sorry, I was not fully listening to what you were
No, no, I
asking,
didn't
but yeah.
ask the question clearly as I could the first time. But yeah, nah,
But
now I
yeah,
get it.
no, that's exactly it, and that's why Michelson, Morley, and relativity and all that stuff is so important, because it's all intertwined. Because in order to sell you a conceptual model based on a ratio of time, it's like you got to go hard, dude. So when they started taking their measurements, and it completely contradicted their conceptual model of the heavens. I mean, that's their claim to linking the celestial and terrestrial sphere models. Because other than that, it's based off of a fictitious observer.
Yeah, no, I get it. No, totally. That's it. I'm done with my question. My bad. I'm glad I got those questions answered.
I'm just wondering, is Kofi gonna bring the smoke now? I think he has some questions for you guys.
Yeah, let's get to the J factor.
Oh, well, real quick before we
Yeah,
move
no,
on,
I
to that
actually
one
had a
guy's
question
question
for
about the
Mike in
stars.
verbatim. I wanted to know how
Hold on, real quick.
he.
What's his name was trying to say something real quick before you ask Mike your question. What were you trying to say? My bad.
Yeah, I'm sorry. That guy that asked the question earlier, his question got overheard. Shane didn't hear him, and then he was talking about his own thing. But that guy's question about why are certain stars visible only at certain times a year or whatever, and that's just part of the sky moving. Like that's it doesn't have anything to do with the like ball curve. Those stars are out of your position now. Like the sky is oscillating. But anyway, that would be my answer. So anyway, I just wanted to answer that guy's question because it did get overshadowed a minute or for a minute. But anyway, go ahead, coffee, whenever you're ready.
No, I basically want to ask Mike, how did he find that this refraction offset was equal to d squared over r2?
So that's a good question, and I was I was reading Gigi Bennett's 1982, let me see, 1982 paper, I believe it was, where he was describing how he was consolidating the various refraction equations, and looking at his curve, I was beginning to realize that that curve is just compensating for the viewing angle, and the viewing angle in everything I'd read about theodolites, that our globe Earth friends believe that the a terrestrial theodolite measurement is accurate, and it measures what they expect for globe Earth. But I was realizing that in Gigi Bennett's celestial refraction, the curve of the Earth was built into that measurement. And so I began looking into, well, does the same thing happen with terrestrial refraction? And the conclusion I came to is, yes, it does. Um, and and uh, that's when I first began mentioning the entire illusion of a globe Earth is entirely built into refraction, and it doesn't matter whether you're dealing with terrestrial refraction or celestial refraction. The curvature of the Earth is built into the refraction, and so it was essential to eliminate refraction from the measurement. And so that's what got me started on that.
Wow.
Okay, is because it sounds like more of a self-realization. Is there anywhere outside yourself that this is corroborated, right? Any other observations that could entail this? Because when I looked at the graph and worked out some of it for myself, I seen that, and I may not be the best with it, but I seen that you had an 11th of a degree um that was unaccounted for. And I was like, so it doesn't match up 1 to 1, right? If there's still some missing. So how did you reconcile for the unaccounted?
Well, actually, what you brought up is specifically what tipped me off that this is where the globe is hiding. It's because the there's always a discrepancy in refraction adjustments. They have to account for pressure. They have to account for temperature. They have to account for um, the infrared transmission of the air. They have to correct for the wind speed. And I began realizing every argument that where somebody is using something involving refraction to demonstrate that the Earth is a globe, what they're really doing is they're cherry picking their conditions to give them the answer they're looking for. And I did a bunch of calculations where I realized this every time. This is where the illusion of a globe is hiding, and that's why it was so important for me to find a way to eliminate refraction totally, and um, and then of course having a peak occluded star that cinches it. When the star's gone, refraction had nothing to do with this. That peak just intercepted the starlight.
Okay, so there's no other corroborated observation that matches this foreseen data.
There is nothing to corroborate the validity of refraction. Period. I've read a lot of supposedly scientific papers about this, but you start reading this, and what you find is just it's people firmly believe refraction is real, and the Earth is a globe, and therefore, of course, the refraction follows the globe because it's a globe, and that's not it at all. No, refraction is a necessary evil for our globe Earth friends, but for the celestial theodolite, it's totally irrelevant.
Yeah.
which we
And
show.
real quick, Coffee. I put a link to a spreadsheet, or Cat put a link to a spreadsheet in the chat, and it has the calculations for the, like, if you enter a distance and the elevation difference, it'll give you the calculation for a flat Earth prediction versus a globe, like, and then what the globe drop would be. And it also applies a celestial refraction coefficient to the difference. And you can see the comparison, like celestial refraction and terrestrial end up making the difference up every time, or it'll be over. It's actually over, but it compensates for it on the back end. So you can, to kind of quantify what Mike was saying with the relationship when he looked at the formulas. And I think I'm not sure if I went over this last time I was here, but when I started looking into the celestial refraction corrections and how they were derived, the input is the globe and the output is the globe. And the reason for that is because they're integrating real world measurements into their model, and then they just computate the curve fit for that to get what the value would have to be to multiply to that angle, so that it'll come out to be where the globe needs it to be with respect to 15 degrees per hour. So it's all computational based, and it's not based off
Yikes.
of anything real. It's just like where it has to be. And there's even I can give you some references where the authors of the paper even said themselves that they would like to see more experimental evidence to back up what they're computating, but unfortunately that's not, what they do.
You know, it's funny. I had my day actually started this morning with a interaction in a coffee shop in Manhattan where a lady gave me this book, Bernoulli's Fallacy, and it literally gets into this. It's really
Yo.
talking. I don't know if you're familiar with the word, but it's literally talking about how. So my day. This is like the first interaction I had this morning, like 7 in the morning, and it was about. It's really about when science took this turn toward pretty much using statistics and like empirical statistics to kind of like fucking lie to itself and just sell anything it wants to sell, and like it's like you have like a replica. What do you call is it a what's the word I'm looking for? A crisis to have and a reproducibility. What is it?
60% of the people in this room are believing what you're saying right now, or whatever.
Philosophy disguised as science, bro. That's the heart of it, really.
It was just a
Yep.
little, historic journey into when things took a turn toward that direction, and astronomy is kind of at the center of it.
It was back when they were like, "Hey, we're not at the center, but we just want to choose. It looks like it is. It measures that it is for all observed intents and purposes. It looks like it, but we'll pretend that we're not because gross." Right? That's the whole Copernican principle, and then the
Yeah,
whole
how far away is that light? How far away is that light?
from
Yeah,
that you get must
a
be glow.
trillion light years. Yeah,
And
okay.
then from that, you get defining refraction to curve at the exact rate of the Earth. And then from that, you get defining a light ray to like curve around Earth, which is what Mike noticed, right? He's like, there's no way you can apply refraction with the radius of Earth built in to have the ray automatically arc at the required rate into an observation with light. Like, obviously, that's always going to lose. So he came up with this. But Coffee said there was something missing. I don't know what that means. I've never seen any missing measurements. Everything in here is extremely quantified. So I don't know what that is. But like, so the basic premise for him was he made the flat Earth prediction. He'd subtracted the Earth curve drop over that distance. He added in the celestial refraction, and each one of
Yeah, but
those.
what I was trying to point out is that Gigi Bennett's refraction doesn't account for the amount of dip in that 203 meters of curvature. That's what I was trying to point out. It doesn't account for all of it. There's still some left over. It's about 11 for a degree, which is about what, 6 arc minutes in a sense. So that's pretty big in sense of a celestial observation.
Which one are you talking about? You talking about Pike's Peak? Well, the Bennett's refraction is 15 arc minutes. Which one are you talking about?
Well, and Bennett pointed
Yeah, I
out
was
in
talking
his
about
paper that
Pikes Peak.
Bennett pointed out in his paper that the reason he came up with his equation is because there were literally hundreds of different refraction equations, all having little deviations in the magnitude of what you're talking about, and many much worse than that, and so the refractions didn't agree, and he was trying to consolidate it into one equation everybody could use that would give better results. And his equation is by no means perfect. What I did notice is that his seems to be the equation that Stellarium is actually emulating. Um, when I plugged his equation into my spreadsheet in place of Stellarium's refraction, it was giving answers that I could not tell from Stellarium's answer. But the whole point of celestial theodolite is, since you can't trust refraction and it's constantly changing, let's eliminate it from the equation altogether.
So there's nothing here with any conclusive authority, right? There's nothing that it lacks conviction. If I could find the perfect words for it.
Oh, are you talking about how they derive the celestial refraction coefficients? I agree.
GG.
You're breaking up, Coffee. But are you still saying that uh, a star that you don't see still requires a refraction? Is that what you're still getting at?
Okay, here's a
Not a,
question I asked Jesse the last time when you got. I was trying to get someone in the room to help out who was more familiar with the data set. But I was asking Jesse. I said, from my understanding, my question is: so if we, because I kept pointing out the data, the more like the manpower, the more data will bear this out clearer and clearer as time goes on. And my question was: is your understanding so far from looking at the data and your prediction that if we just had flat Earth, because they're accusing Jesse and John were accusing Mike of they were being a little bit more nefarious. They weren't saying it was a coincidence, but that he cherry picked indeed a range that could sort of match a flat Earth prediction and kind of get lucky. And that before, shorter than that range and longer than that range is going to fall apart pretty quickly in favor of the globe. And my question is, so if we just randomly went out and we did actual predictions, right? Could the globe use globe math and make predictions with, and let's say we completely shelved refraction entirely, we put refraction on the shelf and we just dealt with a geometric prediction. I would assume, in my opinion, that the flat earthers would always end up closer to the mark than the globe earthers in a bigger range of distances and peaks or whatever. And I was told that no, it would absolutely work in favor of the globe.
Only
So
Real quick.
so
Uh,
I got a direct answer for that. Okay, so Kat and I got a C star and did random observations at random distances. We would drive around wherever we landed at a good spot. We would set up and see if we got occlusions. One of the distances we used was like 5.4 miles, and I forget our elevation or whatever, but that one was basically indistinguishable from the globe in terms of angular difference and all that. And then we did one from, I think it was 50.4 kilometers, or was it 40.5? I can't remember. It was in the 50s. I'll have to look at it in a second. But we did that one as well. That one was flat Earth. Now, if you want to get a globe Earth observation, and Jesse can confirm this, you have to do it at sea level because there's going to be enough and for far enough distance at an elevation low enough in terms of the peak, uh, so that the celestial refraction correction matches the expected globe drop.
So my question is ultimately, do you think that that range where you could get lucky and actual refractive conditions could help match, a geometric globe prediction? Do you think that,
No,
so which
no,
sliver, who has the
no,
biggest
no,
sliver,
because
I guess?
No, because the second part of Mike's analysis, where we can backwards derive the elevation based off of the occlusion timing, the globe is off every time because and in addition to that, they're locked into their refracted angle, so they can never even have our angle. Like they literally need their own timing, and they're scrambling to try and find or trying to take ours or obfuscate it and make it seem like the methodology is invalid. It's like while simultaneously using it to uh, show emergences and occlusions based off of the same principles that we're doing. So, you know,
You know what's the crazy part, Alan? I accuse you guys of doing the exact same thing. That's the crazy shit. Like, I honestly do. You feel me?
Okay.
Because at the end of the day, right? I mean, through Mike's works, he just proved it. You could use one refraction equation and another. You could use Gigi Bennett's, right? There's no conclusive authority to which formula you're using. So this shit could go either way. There's
No,
no bearing
no.
No,
He,
no,
he
to
no.
said
any
the
of
he said
this.
the
Whoa, whoa, whoa,
Like,
opposite
whoa.
of
One
that.
second, one second, one second.
without the J factor, like it's
Yo,
uh,
there's absolutely no J factor included in this. We're specifically talking in our analysis about backwards deriving the elevation angle from the time in which it was occluded to get what that would be in meters for the mountain. We're not J factoring anything at all. Like what was stated at the beginning, the J factor is a supplementary analysis that you could do to clean up the data to make it more obvious. Because when you do it just based off of the occlusion timing and backwards deriving the elevation, it's the globe literally can't do it. And what you're mistaking about refraction is that the occlusion process is entirely physical. So some of the, or I'll have Kat put a link to the celestial theodolite Prezi where you can watch the videos and look at the slides. But what we showed is that a refracted object does not block refracted starlight. Taylor showed that with a knife and a cup of water. And then also Goose made a rig with a dowel where he showed that when you add a refractive medium between you and what you're observing, the starlight on the other side has to go down a little further before it's occluded. So there has to be like the refraction, even with refraction, right? Even with any amount of refraction that you want to consider on your side, when that physical intersection happens, it's no longer visible. So you still require a different timing. Like that was you drew the completely wrong conclusion there on what I said.
But dude, he also said that it doesn't matter what
nah. I
formula.
think you missed. I think you
That's
misheard what I said. I wasn't trying to accuse you of applying the J factor to your measurements or cat's measurements. What I was saying that without it, right, it just falls back to which eyes you choose to look at this experiment or observation with. Globe eyes or flat eyes, because from what I'm seeing in the data that I'm getting, it falls either way without the obscurity of the J factor.
not
Yo, real
you.
quick,
You
on
Falls
the
only
either
top,
think
way.
because
It
that
it
just
is my
if
it
you
first
just
listen to
day.
it just
people who lie
Real
about
quick.
it.
it
That's the
just
only reason.
relies
Hold
on
on.
whether you want to account for curvature and refraction or not.
Yeah.
That's
Real,
literally all it falls down to.
Wait a minute, really quick,
no,
guys, from the
no.
top. Can somebody just from the top just tell me what the hell a J? It sounds cool as hell. I'm not sure what the J factor. My first time hearing it today was the story of the J factor.
Yeah, go ahead. The J factor was
I
a
thought we was being
correction
anti-Semitic
that
for
was
a minute.
applied.
I'm glad somebody asked. Go ahead.
Yeah, so Mike was attempting to calibrate the celestial theodolite, right? So he came up with a method where you do an azimuth correction to get the what do you call it? So basically, like you're X distance away from the mountain, but when you go to the mountain, that because the longitude of the spherical coordinate system, it's going to be off a little bit. So what he was doing was correcting for when the azimuths align up to the mountain peak from when it's observed from the observer at X distance away to be generous to the globe to make it fit the perfect globe correction. And that was the premise for applying that. And when you do that, it cleaned up all the data in that way. And people are calling it a fudge factor, et cetera. And that's fine. Like we don't even have to use that part of the analysis because the important part, as Coffee maybe didn't understand there, was when you backwards derive the elevation that based off of the occlusion time, it like the globe literally can't even agree with it because you're based off of an apparent angle and the mountain's angle, like the mountain's elevation is the mountain's elevation, so like you're off every time.
But dude,
Yeah, that's my point. You could choose to look at it with curvature drop or not.
What?
It's the
no,
same. It's exactly what I'm proving. I
bro.
told you guys this shit earlier.
No.
Like,
So what you said was any formula will do, and that's specifically the opposite of what he found. What he found was the geometric Earth curve drop, which is equivalent to 360 times the distance over 2 pi r, also known as d squared over 2r, also derived from r times 1 times the cosine of d over r, are all equivalent to geometric Earth curve. That's what he found. So when you go to the actual position and use stellarium, what stellarium will show you for the atmosphere on prediction will be the refracted geometric position all the time. That's why all of his data is divided into those three things: flat, geometric globe, and refracted geometric globe, because the only one is just the G.G. Bennett, one is drop over distance for Earth, and the baseline is flat Earth. That's why he built the sheet that way. That's the only formulas that's used, and that's why he said he could use stellarium, because those are the three corrections, and that's why all the data has three. Hope that helps, dude.
Yeah, it holds perfect. It just proves what I've been saying this whole time, guys. It doesn't matter which, like, it doesn't matter without this J factor.
No, no,
It
no.
just depends what lens you look at it with.
No,
It
the J
literally
factor
does.
is irrelevant and not used in any of the analysis I just put forward. Like, if you go and just do if
Yeah,
you
I know.
do
I
the
never said it was.
prediction,
I'm
well,
saying
it's
without it, without
Listen,
it, because at the end of the day, right? Does the J factor change the timing or not?
it doesn't matter. No, it doesn't change anything. It doesn't change one single observation point to be closer to globe or anything. It's a further post hoc analysis from the data, right? It doesn't actually change the data.
yeah, coffee. When I'm talking about backwards deriving the elevation, that's not part of the J factor process. And your conclusion about looking at it from any perspective is, again, it doesn't make sense because the elevation is the elevation of the mountain, and only one of the predictions matches the actual elevation, or is closer enough to what the actual elevation is. So, like the way when you're saying like,
Until you
yeah,
account for
so
curvature
so,
drop,
so
because once you
dude,
account for
what?
curvature drop, it just comes right close to the globe
No,
prediction.
always wrong.
So
When you
No,
it
use it, it's
depends
no,
on
wrong.
what
coffee,
you account for.
coffee, coffee. Please don't interrupt me. And obviously, we accounted for curvature, bro. That's the premise. We're comparing the two. Like what you're saying right now is like it's low key incoherent.
I haven't even looked at the data. It sounds like you just listened to Jesse, bro, which is abhorrent.
Huge, yeah, huge mistake. You should go look at the data,
Yeah,
and
yeah. No,
then
I
hey,
think
hey, coffee, coffee. While you're looking at the
concluded with
data, here's what you're
Jesse
saying. Like,
on this for the
look at
first
look.
time in
Oh, did you
Clubhouse.
now? That's fine.
You feel
Check
what I'm
this out.
saying?
Go to the spreadsheet. You feel what I'm saying? And look at the elevations for Jesse's
Bruh, I
equation,
checked the
and look at
spreadsheet.
ours.
All the
Oh, no
discrepancies
way.
line up to
So
curvature
you can
drop
see,
for
the
each
consistency.
observation,
That
whether he
Jesse
moves
changed
the
his
mountain peak
elevation
or
to try
not.
to make it match
I'm
what the
not
globe
bugging.
predicts.
It's in the
Hold on,
data.
yo, one at a
Oh,
time,
that's
fellas.
so
Come on.
cool, bro. That's fucking tight. So you're saying that when you went to Jesse's spreadsheet and you saw his elevation adjustments and you saw that we didn't do that at all, but you saw him J factoring his own data to make it fit, to make it give the appearance that it fits the globe better. You're saying that you are on board with that, and like I'm wrong, like bro,
You know, he didn't notice that. He didn't look at
I'm
anyone's
talking
data,
about the
bro.
we're gonna have to move
spreadsheet
on. Like I don't think
provided
you
in the
even look at
Celestial
it.
update. My brother, the Celestial Theodolite update. I have all of them.
Then okay, so listen, go look at the elevation differences then, and go look at what the actual elevations of the mountains are. So like your conclusion is like erroneous. It doesn't even make sense. How could you draw the conclusion that you could look at it through any aspect of the data when only one data set it matches what the elevations of the mountains are?
Well, that's
That
what
doesn't.
Jesse tells everyone. So people who don't actually look at it will just believe that. That's what I think I'm gathering from
That's
this.
crazy, dude. Are
Bruh,
you
I
That's
are
said
you
that
ridiculous,
in the
right?
first
serious?
10 minutes of, you can ask anybody in this room. This is what I said in the first 10 minutes of this presentation. When you first presented it in this room, I said that in 10
It
minutes.
was wrong then,
I
dude, and
just
it's
had to
wrong
comb
And
now.
through
it
the
was just
data
as
just to
wrong
confirm it.
then as it is now, bro. We've literally been trying to get you to understand you like the issue. I'm not trying to be rude, but if that's your conclusion that you're drawing, you don't understand the issue.
Is there any way that that you guys could like walk through any of
Yeah.
Yep.
just to show
Yep.
where the discrepancies are, and then explain like why it's not a discrepancy?
Absolutely. If Kat, if you could put the Discord link to the Flat Earth Gang in there, you guys can follow along in the main chat to look at the images. Shane, if you want to go over some of the measurements that you posted and explain the graph and how it works, and I highly recommend. Let's see, can we put a link to, do you have your Canva link also? We
Yeah.
could put that in the chat as well, put the Canva in there. I highly recommend pulling one of these bad boys up so we could all go over it together, because being on the same page is going to be extremely important moving forward as the complexity of this conversation is about to increase tenfold.
But I mean, to be clear, I did this so that would simplify it, right? I did a little depiction of the flagship example, a couple other examples, just so we could break it down to basics so that we can clear up obfuscation and confusion just like this, right? So if you look at the image here, I'll just describe it. It's got a triangle and it's got a dude on the right, and he doesn't have a theodolite in this example. All he's got is an old school camcorder, and it's black and white, and he's got an old school marine chronometer. So he knows all he can tell with these tools is that there was a star occluded by a mountain peak. So he has no idea what angle that star was at. He has no idea what it was, at what angle it was occluded. His device doesn't have tick marks, doesn't have anything to tell what angle it is. All he's made it is the observation of the occlusion. With that, you have two other pieces of information. You know that the altitude of Pikes Peak is 4,300 meters, and the dude who made the observation was 2,073 meters above sea level. So all of that is all the information that you need. Nothing further is added. From these three things, we're deducing, hey, arctan of rise over run to get our prediction for the height of that mountain is just going to be, 4,200 of the 4,300, the height of the peak minus 2,073, height of the observer above sea level, over 50,700. That gives us our flagship 2 degrees 31 minutes, right? That's the flat Earth elevation angle for that peak to be occluded by that star. From there, you add for the globe, you subtract from the flat Earth prediction the globe geometric prediction, which is, like I said before, the equivalent of 360 over 2 pi r times the distance, or d squared over 2r, or r times 1 minus the cosine of d over r, all giving you, once you do the math for this distance, an approximate increase, a decrease 27 minutes, 22 seconds. So you have 231 minus 27 minutes, and then you add in your G.G. Bennett celestial refraction, 15 minutes. That brings the globe prediction to 2 degrees, 17 minutes. Now that is confirmed by Jesse Ruhiff and every other glober. No other person disagrees with that as the globe prediction. So we've deduced the globe prediction and the flat Earth prediction. We have the observer over here in the corner has no way to deduce what angle that was at. All he knows is that he calculated it would be at 231. Now you go to your favorite nautical almanac or stellarium or whatever star position. You reference the time of the occlusion that you recorded with your chronometer over here. You do the math from the local sidereal time to get the true position, or you reference stellarium, whichever you want to do, and you find out that true position is actually 2 degrees 32 minutes 51 seconds at the exact time it was occluded. So you see the flat Earth prediction of 2 degrees 31 minutes is spot on for this particular example, and for every example subsequently. And the final part is that now you construct a new triangle and you determine the height of that baseline, because now you have a true angle, right? Our angle is 231, 2 degrees 31 minutes. The globe angle, 2 degrees 17 minutes. So from there, you do some basic trig. You do, say, that same distance, 50,700 meters times the tangent of 2 degrees 31 minutes. So you do the inverse of what you started with, and you get that height, which is 2,226 meters, which equals, the exact height of Pikes Peak. If you do the globe equivalent, 50,700 kilometers times the tangent of 2 degrees 17 minutes, the locked in refracted globe angle, you get 2,025 meters, 200 meters off from the height of Pikes Peak. And that's the data that Mike graphed, the difference in the predicted height at the end. So there's no factor, there's nothing else applied. The only thing that you knew was the time of occlusion and that it was occluded, right? That's the only thing you do. So with those observations is how the whole process works. That's why nothing is relevant from the observer to wherever to get the other refraction. All we can deduce is our prediction with the math, and then we add in refraction and remove Earth curve. Now that's the basic structure for all 43 of these data points, and that's how each one of them unfolds.
Coffee.
And also, you should definitely look at the spreadsheet if you literally haven't seen it yet. That's crazy.
Thanks for the breakdown, Shane.
Awesome breakdown. And he said that he did see it, by the way. He said he had it.
Oh, make sure
There have
before
been
you
a lot
guys
of
get out of here.
spreadsheets, by the way, as well. So to be fair.
Before you guys get out of here, I had a $200 bet with John that I suspect Jesse was capping about. I didn't really, I'll pay John off if he's right, but I just want to make sure I get somebody who's familiar with the data and Jesse's simulation. Because I remember, I remember actually, was Alan parking on Jesse one time about his simulation applying the refractive corrections to flat Earth angles, and it seemed like Jesse was kind of conceding that as much. He was saying he did it because it didn't matter, and you were challenging him to just so then do it with the globe. And then Jesse, that was all I was pretty much betting, that that's indeed what Jesse conceded to. And John said no, that would be a really big problem if Jesse did that, and Jesse said you
So
didn't do that. So
here's the
Did Mike
thing.
leave or my Mike still here?
He's still
Nice
here.
here.
Jesse did go on to say that he later, fixed it or whatever. But the thing is though, when you're doing celestial navigation, you're not out there making globe Earth adjustments
globe
to whatever the thing
corrections.
is. You're just doing a raw flat. You're just doing your raw trig, assuming that the tangent to the horizon is on a sphere. So so in practical navigation, like literally when just adding that correction, it makes it come out to be what it needs to be to keep the star coplanar to maintain the 15 degree per hour relationship that they need
Right.
related to a position on the ground. So thanks to John for agreeing that is a problem. That's why we uh, are questioning these celestial refraction corrections, right? That's why we're testing their conceptual model using this, because if you try to reference it internally with the optical position, it's going to be internally consistent.
Hey, Dr. Mike, are you're available for a question? Just kind of want you to elaborate on
Yes, I
something
am.
real quick. Awesome.
Yep, go ahead.
So what inspired you to make the J value and its name in the first place?
Well, it's named in honor of Jesse, actually. Um, he gave me the idea when he suggested that we get our distances from the NOAA website. I had been using a website called Movable
Movable
Types.
types.
Yeah, and he said that wasn't as accurate, and no one did a much better job. So I took his suggestion, I tried it, and with the movable types, you're lucky if you get within 10 meters, and I'd swear a lot of times they round it off to the nearest 50 meters, but whereas NOAA gives you 4 decimal places, so it gets you down to a tenth of a millimeter. So I started switching data over to NOAA, and then when I saw how much that cleaned up the data, that's when I realized, well, the bearings are a little off. Um, so these what Stellarium is telling us the bearings are for these stars is not quite right. And so I added, and I realized that using the right ascension and declination equation that converts to azimuth and elevation, um, just by adjusting the timing of that, I could um, uh, shift the heading a little bit to align it with where it belonged. And after I did that to a few of them, that's when I discovered that I can make the globe Earth prediction without refraction correction. I can make that perfect. And when I make that perfect, that makes everything else perfect. So it drastically cleans up the data, and you don't really need that because you just take raw data and you can clearly see that the flat Earth angles are closest to no deviation, and the globe Earth angles are pretty far off. But when you add the J factor, it makes the lines so clean. It removes all doubt that the flat Earth prediction is virtually on top of the zero deviation line, and the globe Earth prediction without refraction is way below the zero deviation line. The globe Earth prediction with refraction is generally above it. Occasionally, for really distant peaks, like we have North Peak, which is 82 miles away. That one is way below, but in general, with refraction, the globe Earth estimates are um, uh, well above zero deviation.
Got you. So it was just a way for you to clean up the data by changing, uh, what was it, the bearings that you initially had from movable types to something more accurate to NOAA. That cleaned it up pretty nice. And then you also wanted to fix the right ascension and declination conversion to alt as well. So there's like kind of a two-parter thing.
So you're close. It started out being just a bearing correction, and it was a bearing correction using timing, little plus or minus um, time offsets from that would just add or subtract from the observed time until the heading lined up. Um, but it was a way of using time to um, fine adjust the conversion from right ascension to declination to as and L. And it was only the as that I really cared about because some of the azimuths um, coming from Stellarium were not quite right. And then modern versions of the spreadsheet actually have the equivalent of Stellarium built right into the spreadsheet. So it's a much more automated process than it used to be. But it was all about fixing little deviations that were you could look at the data and tell that that was not the right bearing, and so it started out being a way to correct the bearing, but um, it unexpectedly cleaned up absolutely everything, globe Earth and flat Earth angles. And so it's just a convenience, and the spreadsheets allow you to turn that on and off, so you can choose whether you want that or you want to see raw data. You get the same results either way. Is this with the J factor, things are noticeably much cleaner.
All
I
right,
actually
again,
have a
so
I
I had a
actually have
question.
a question for Coffee
All right,
real
go ahead.
quick. Are you sure that I asked him earlier? Are you sure that you wasn't misunderstanding, or you misunderstood what the J factor was? And because he said that this is where the J factor was where the fudging happened. I don't really want to put words into your mouth, Coffee. You could say it yourself,
No,
but
you're good. He
this
got that from Jesse. Jesse kind of like throws words around like fudge factor for no reason, just to kind of
sweet,
poison the well. It's
Yeah, he
kind of
just
retarded.
aggressively lies about it all the time to try and make it sound the
Yeah,
worst.
he's a deceiver, dude.
Yeah, the
amazing.
first time I came here, I kind of felt bad for Jesse because he seemed so mild
Don't.
mannered, and I felt
That's
bad
his
like how I
stick.
treated him. And
It's
then the first time I actually had an interaction with him, in the first few seconds, I had to check him like, bro, just fucking like, why you talking to me like that? Like we've never. Why do you think you get to talk to me like that? Like, he just started immediately. Like, if you know anything about basic science, I'm like, bro, you never had a fucking conversation before. Like, let's not get disrespectful right out the gate.
yeah.
Yeah,
Tonight.
Jesse, since you're in here, are you gonna stop calling it
No,
the fudge factor?
nope. Don't care. Don't care what Jesse says. He's not allowed to participate anymore after lying aggressively about everything all the time. He just really goes to all the other groups and tells whatever aggressive lies he gets away with, regardless of what we try to tell him or what we try to learn him. But whatever.
Yeah, he came in so coy and mild mannered, it seemed like, and then quickly. But my question is, all right, so let's say we put refraction fully on the shelf. Nobody touches refraction, just dealing with straight sphere versus plane. We start with 5 mile mountain, then we go to 10 mile, and we keep going in, let's say, 5 mile increments without considering refraction, just making predictions of angles and timing coincidences or whatever. In my understanding is what the data's been bearing out so far is that the flat Earth is a far more reliable assumption that'll get you closer to being able to make a prediction of the timing, and that starting from five going all the way out, both will fall apart eventually, slowly, but that the globe will fall apart a lot faster. Is that correct, or that the globe would never really even get it? Will never be as close as the flat Earth without with no consideration of refraction.
Well, I think for that ratio to even work, like you need a
So,
flat baseline. It's crazy.
so the only way to make, or like they're always going to be off because they're locked into the optical refracted angle, and their geometric angle is never high enough to meet the elevation difference. So that's why Mike's second analysis that he added when it was backwards deriving the elevation of what did the occluding based off of the occlusion angle. Like when you do that, you get the actual elevation of the mountain when you add that elevation plus the actual elevation with respect to sea level. And ours matches more closely to what the actual elevation is, and the only way that could happen is if the Earth isn't a globe.
And Coffee, can you clarify something for me? Was the silver bullet the nadir or was it the J factor? Because I remember Riot talking about the nadir not being taken into account. Am
Oh,
I
the
wrong?
the, the nadir. So nobody takes into account the nadir. When you're in negative coordinate systems, we were kind of touching on this earlier. When you're using your hemisphere, when you're using the celestial sphere, the only part that you're using for, like, to get your latitude and longitude is the stars that you see, and that's going to be marked in positive values. When things go out of your vision due to either Earth curvature or just circling out of your field of vision, you plot them as a negative function, and whether, like, however you want to display that is irrelevant. So, like, there's nothing, like, if that's the silver bullet, you can defer to the stellaria map, and you can enable the globe projection of it, where it's, I think it's called the equatorial projection or something like that, or you could look at it as the azimuthal projection, and that one makes the stars circle above you, the other one makes them go beneath your feet. They're literally the same thing. Like, they're kinematically equivalent. Like, it's built into Stellarium.
Yeah, hemisphere and
Dude,
spherical are identical.
the silver bullet, the fudge factor, these sly ass tactical maneuvers from these guys. It's fucking pathetic, dude.
I know you guys pissed off Coffee because he left.
I got a quick
So,
question about
yeah,
Uh,
so
refraction, if I may. Um, so
absolutely.
this is really for my comprehension, but so I understand the method was devised to eliminate refraction, and so we're taking angles to mountain peaks, we're recording the occult timings, and we're comparing them to each model. So my question is refraction actually completely eliminated from the equation, or is there still a little refraction being accounted for in the flat Earth computations? I just don't quite understand that.
No refraction in flat Earth. We do account for it in the globe, though, perfectly with Gigi Bennett.
Gotcha.
that's
Okay.
the that's the point of using an occlusion timing, right? It's like when
Right.
you can't see it.
I feel like I've heard Alan say
No,
things where
no,
there's
you're
a
good.
little negligible refraction still included, but I just wasn't
Yeah,
sure about that.
yeah. So when there's refraction between the star and the mountain peak, right? Like, there's going to be some of that, but it's not
Okay,
going to be
I got you. Yes.
but it's not going to be to the entire tune of the exact ratio of the missing difference,
Right.
because
Gotcha.
because it's
Gotcha. Gotcha. The
oh,
terrestrial refraction. Yeah.
right, a star is just a little point source of light. If you look at it through a telescope, it's about, or like the recording devices that we're using for this, it's about an arc minute or an arc minute and a half in size, very, very small. And
It's not
so
gonna raise it
so
22
so,
arc
so
minutes up or whatever.
yeah,
Gotcha. Okay, that
right.
makes a lot of sense. I totally understand now.
Yeah, yep, yep. Awesome. So it's like, even with it, that's why we don't care, because even with it, they still need a different timing. And I can get you a link to, I think it was Celestial Theodolite update number 10. Our good buddy Goose built a rig where he demonstrates this, where he shows what the refractive index, or what the refractive angle is, with no refraction medium or refractive medium between the light source and the observer, and then when he added a medium, the occlusion timing does change. So they literally can't have our
Gotcha.
angle.
Yeah,
The
I saw
intersection
that.
has to be
I just
physical.
it takes a few times to hit me in the head for me to get
Oh,
this.
no worries. No worries. Awesome.
You know,
Awesome that you saw it. I'll have Pat throw a link in there anyway for anyone else. But awesome.
I don't know if anyone dropped this link already, but what would probably be good to show him and also to demonstrate for anybody is those I think it was, what's her name, Taylor had showed like the little like water in a beaker and showing that the refracted
The
image can't
knife. Yeah.
block the
Yeah, if you go to this Canva link, it has everything we've ever made, a whole bunch of new slides in that video, and a bunch of everything.
Wait, Cat, you're mod now, right? Can you poke? You guys know how to do that, or tell
Oh yeah,
Cat to
yeah. I
do
made
that?
you a podcast so you can pin. This is like pinned link. You just gotta click that on the top and it lets you pin a link on the top of the room. Whatever we're talking about at the time, you can pin it so everyone can see it. I'll
Kind
do
of
it
just
too.
kind of crowding the chat with dog
I'm
water
not
arguments
sure
from.
how to pin it.
I got
Once
you.
I
Let me see.
post the link, how do I pin it?
About to figure it out right now. I'll tell you. So you click the three dots at the top of the page, and then you should pop. It should pop up, and it says you see a little drop down. It says pinned link, and once you click that, it'll tell you to enter the URL. I'm doing it right now.
Pin link. Gotcha.
I just did it. I just put it up there for you.
Perfect.
So
Oh, it's
whenever you want
over,
to
you
change it.
guys. It's over. She's about to pin some links. You guys can't have any excuses.
There it is, right there.
Nah,
Can you just
I
do
felt a little
one
bit
pin
like
linked at a time, or can you pin more?
one at a time, man.
One at a
I feel
time.
like y'all
Okay.
low key shitting on us
Place
on
the last
Clubhouse.
one.
I heard, I think it was Alan called us the Clubhouse permanent. I felt like it was kind of like a pejorative. I don't know how to feel about. You mean we call it Clubhouse permanent? Like,
Clubhouse
There
permanent.
was some slight social shame there to get you to go to Discord.
Yeah,
Dude, you
screen
guys,
share.
the Clubhouse
you guys
permanent. So
need to get on Discord, dude.
Like
Like,
screen share
you
is pivotal,
nah, for
dude.
sure.
Your whole experience going crazy.
screen share, just archives, just immediate access to different voice channels, and it's crazy how
Like
you guys are not
TikTok, like
there.
it's TikTok is too like I guess that's where everything
Oh
is
man,
just too fuck. I'm a boomer. It's a little too noisy for me. I catch the TikTok shit a week later when it lands on Instagram. Like I catch you guys
no, that's all
Tik
discourse and shit
garbage.
on
TikTok
YouTube.
sucks. Yeah, no, I agree with you there.
I just feel like I catch all the good content on YouTube anyway. Like after you guys stream it on.
Yeah, but I mean, imagine being there, it's like live, and then like actually being able to interact. And I don't know. You guys got to get on Discord, dude. It's time. It's time.
Yeah, and my
Clubhouse, you were
bad.
cool. You were cool and all, but like, it's time.
Yeah, my bad. I kind of races towards Shane's towards Shane's shit because I always go to Space Order to catch up on anything that you guys drop, and I know Shane is always streaming too. My bad, Shane. I'm gonna try to give you some views
That
too.
is
My bad.
racist, definitely. Yeah.
Yeah, it's like by default, bro. I was just typing Space Audits, you know what I'm saying, to check out whatever I missed.
That's what I do too.
So you're guilty like me.
I think I have Space Audits bookmarked on my browser tab and not my own channel because I can just go to YouTube or whatever and go to your account. Yo,
Damn. So any more contentions? No, nobody.
the simplification really helps because then it kind of breaks down the understanding of what we're talking about and the simplest components, especially when people try to add layers to it and things that aren't necessary, right?
Well, Shane, what was some of the stuff we were talking about earlier in regards to the difference in angle predictions with 11 arc minutes versus 22 arc minutes? Because that's a hugely important concept to go over because we're dealing with the geometric versus the optical and like how that math relates and how the missing 11 is already in there. They're adding it back with the refraction.
Yeah. Yeah, I think Mike went over that really well. But essentially, it's all the discrepancy over the really small angles have an accounted for portion of geometric earth drop that's technically for the geometric position would account for it twice, and for the optic position it would only be once. So it comes out like optically like 11 arc minutes and geometrically 22 arc minutes. But the way that it balances out is that we add one and subtract the other, right? Because we do the drop over distance, we subtract that from the flat, and then we add in celestial refraction. So double drop over distance accounts itself. It equals the exact same prediction as Jesse was contending, but the difference is like when would you apply one or the other? I think, right? Because if you approximate it, right here. So celestial refraction lifts it back up, but the double dip actually creates like that illusion of curvature. So like the uh the actual 22 arc minutes full tilt uncorrected dip is what you get for geometric, and it produces the exact same offset of 11 arc minutes tilt for the atmosphere on in stellarium. So that's how we match our predictions, right? Is that our prediction with refraction on matches the glow prediction and all of these predictions. And when you account for it that way, it matches even the small angles that Jesse tries to bring up below a half a degree. D3, I think you're hot, Mike.
Did you make that coffee?
D3, you're definitely hot, Mike.
Yeah, man. I was we were talking a little bit about the meta earlier, and because someone's kind of asking like the why question. I'm just like, man, like if you give these people that fucking magic wand, if you give them that gaslighting ability, man, that blank check to just tell, like, as I'm sitting here talking right now, I'm literally looking at a star. And I'm just imagining a guy next to me being able to tell me, yeah, you see it there, but it's where I say it is. Like, look over here at this paper. Like, man, it's That's a lot of power to give somebody, man. Like the implications here, it's far reaching, man.
Yeah, that's what the Buddhist monks were fighting against, and they lost the battle even with a working conceptual model to show the equivalence between the two. So it's going to be a rough battle ahead, boys, but the, you know, onward we go. They're going to do what they're going to do.
They're running out of stuff, though, man. They're running out of arguments. I feel like.
Well, if I just say Silver Bullet and Fudge Factor a bunch, I'm sure I'll get people like Teddy over here to just chant that, and that'll be enough. I can make a YouTube out of that.
We need a flatter. Yo, but something off topic. Stone. When is the thing that you're gonna do on? Isn't it on Glowbusters? When is that?
Hey guys, yeah. As a matter of fact, it will be. I'm all lined up for this Sunday afternoon. Absolutely.
Sunday afternoon. What time? Like well, I guess Eastern.
I think it's 3 Eastern.
3
And
Eastern, yes, sir.
yeah, and we're going to do a recap of the Shadow Sets deal. It's going to be good.
Oh,
Yeah, man.
Nice.
I love the
Yeah, I feel like
shadow
it's a
sets
really
presence.
slept on one. The Cell Theo's been taking up all, has been all the rage, but the Shadow sets, I'm looking for some more, some rebuttals and some more, action on that side of things. I haven't really heard too many.
I'd like to see some stuff on our side as well. I'd like to see some replication. I'd like to see some of you guys actually duplicate what I did and show me some data. You know what I mean? That's what's really important here. Not necessarily the objections that we're going to defeat. Extra,
Good point.
reconfirming data. That's what we need.
As Stone likes to say, more data in a cryptic voice.
It's actually get the data. That's my mantra.
But obviously, you guys didn't take into account the three different types of what is it? Uh,
Globies?
Twilight or
what
whatever.
what was it?
There's
Three different
7
types of
different
Globies?
Twilights.
The Twilights, the different types of Twilights.
Oh,
Yes, yeah,
right.
there it
All
is.
the
The
different
Twilight.
Yeah.
Twilights. Right.
What
Right.
was the type of Twilight? What's the closest
You mean
one?
all the shit that happens after the fact? We need a bunch of that for sure.
Well, man, I won't lie, man. It's like there's a lot of bold refraction claims, but tops for me, man, is like the Canada and the idea, like when you see the sun on the horizon, that it's not there, that it's gone already, and you're like, and so like with Canada, like when I think about Canada, what they're saying is the entire image. I mean all of the ambient light, because all you're seeing is the silhouette of Canada
Dude, and the
and
shadow of the mountain
and the
hitting the
so
ground.
so,
How does
but
that
all of that has to be around the horizon, right? All of it. The half a degree sun. I mean, the sun, whatever. The backlight, the cloud. That entire image has to all be not there, right? Am I bugging? Doesn't that have to be the
Yes,
claim that the sun, the mountain,
Have you seen the
the
video?
Dude,
it's two
they
types of
literally,
refraction,
Doesn't
dude. It's
Taylor's
crazy.
light experiment with the knife and the laser also prove that the sun would be occulted, so it shouldn't even be refracting?
Exactly.
right?
that is the overarching implication here with the occlusions being physical.
Wow.
How could there be this big a disconnect? How could they not see that?
Yo, religious belief,
Yeah,
bro.
I think
It's
that they do see
desperation.
it,
It's
and then
desperation.
they intentionally spend time and energy and plan to obfuscate, hide, and misdirect
Uh,
from that, which is my
dude, we
argument.
could ask that question about quantum mechanics, about everything
Right.
Einstein laid down. We could lay that on string theory. We could ask that question all day long.
I think string theory is pretty much out now.
Hey, where did the dude go that was here earlier, man? I told him not to miss this, bro. The dude that said that a flash drive that was full was
Data.
going to
Oh,
weigh
fucking
was going to
Yeah.
John.
weigh more than
Oh,
Data. He said
that was
data is what
crazy,
he said.
man.
He
The
said data
data
is
has
is physical.
mass. Has
It's math.
mass. So like a full hard drive is gonna have it's gonna weigh more than an empty one, like the data.
You guys ever heard that before?
He's trying to assert that digital ones weigh more than digital zeros.
Yes, yes, that's exactly.
What's his unit of measurement?
Yo, I asked him. I said, man, How many zeros after the decimal? It's going to be a lot of zeros. And we just don't have tools sensitive to measure it. I'm like, so bro, what the fuck kind of story? What are you talking about? I'm like, why do you think that's real?
Mm-mm-mm.
I'm like, by
Hey,
that virtue, as I walk down the street and hear music, I'm gaining weight, bro. Because like I'm taking new information in. Like,
real quick though, before does anyone else have any questions for Dr. Mike before he's got to get back to the dogs, or any questions?
oh, did you guys get any international? I remember there was some Czech boys, but you guys any international
I have a question.
observations?
It's
Go ahead,
not
D3.
about what he's doing though. It's something that I'm trying to kind of put together myself. Do you think we could use the gravimetric data that they take to produce the geoid? Originally, it doesn't have shape. Do you think we could take that and use that as a straight baseline?
Hmm.
The Earth's equipotential gravity dependent directional field? No, I don't think so, dude. That's a made
Isn't
up.
a
It's a
geoid
made up intermediate
based
model.
on elevation differences?
Well, let's say when
No,
topography
no.
kind
So
of
so the
planes or
way
whatever.
so the way it is we get gravimetric data on foot via planes, right? But gravimetric data is essentially